Hi, Mr. Alice. So for this first one, you're going to have to use -2 to 2 for t, because see with this one you could use 0 to pi, but the problem with this is if you use pi or any numbers like that, for tan and secant you'll get an undefined term. So what you do is you use -2 to 2, and when you do that you get these numbers here, and when you graph them you end up getting something looking like this, which is a sideways parabola. So when I input -2, I get 1.702, and for x, and then for y, I get -2.537, and that's our starting point, which is right here. And then as we continue to go along, the sideways parabola moves in this direction like this, and goes on from there. With the next problem right here, you have a circle in a sense, or an ellipse technically, but it's basically a circle. So what you do is you input 0 to pi for t to figure out your x and y terms. You'll end up getting these numbers, and then with these numbers you can graph it, and you can tell you start with 1,7, and you go from there to 6,2, 1, -3, -4, 2, back up to 1,7. So that direction is going clockwise. If you want to, you can draw the equation for this one, which would just be x minus 1 squared over 5 squared plus y minus 2 squared over 5 squared equals 1, which is basically a circle with a radius of 5 and a center of 1, 2. This next problem we have is just a simple eliminate the parameter to find the equation. So if we know that x equals t, we can, in a sense, just to eliminate the parameter, plug in x for t, and then you get y equals x squared over 5, which is a parabola, a simple one. And the vertex is going to be 0, 0, because there is no b or c value, so that there's no vertical or horizontal shift. Only the kind of width of the parabola is getting shifted, not the actual parabola itself. That's why the vertex remains 0, 0. With this next problem, we have an ellipse. So we know that the center is 4, -5, and we know that the vertical radius is going to be 2, and the horizontal is 1. So with this information right here, we can figure out the equation for the ellipse. A simple one, you just plug in kind of the numbers, and from there, so you have x minus 4 squared over 1 squared, and this would be kind of the horizontal shift of 1, and then the center 4, and then you have y plus 5 squared over 2 squared. 2 is the vertical shift, and this would be the -5 in the center, which equals 1. And then to get this into a parametric equation, what you're going to want to do is set it, so we know that the trig idea of cosine squared plus sine squared equals 1. We can use that and kind of change it to this equation, so that we know cosine squared equals x minus 4 squared over 1 squared, and sine squared equals y plus 5 squared over 2 squared. With this, you can simplify these into x equals cosine t plus 4, and y equals 2 sine t minus 5. So you can do this, square both sides. This becomes cosine t equals x minus 4, which simplifies to that. This becomes sine t equals y plus 5 over 2, which then simplifies to that. That's how you find the parametric equation from there. With this next problem, with 2 right here, you're going to want to do to start off is solve for that sine 2t and that cosine 2t. So with that, you have sine 2t equals x plus 1 over 3, and y minus 2 over 3 equals cosine 2t. And then from here, you're going to want to get it to that sine squared plus cosine squared equals 1. So what you're going to do is set this equal to each other like that here, square both sides, and then you get sine squared plus cosine squared equals x plus 1 squared over 3 squared, and y minus 2 squared over 3 squared, which equals 1. This is an equation for ellipse, but can also be turned into a circle, which would then be x plus 1 squared plus y minus 2 squared equals 9. This is a circle with a center -1, 2, and a radius of 3. This one is an easy eliminate the parameter to get a simple sideways parabola. So what you do is you know that y equals t. So what you're going to want to do is plug in that y for t squared. So then that becomes x equals y squared over 4, which is a sideways parabola with a vertex of 0, 0. Again, no vertical or horizontal shift because there's no b or c value for this. That's why the vertex just remains 0, 0. Last page. To start off, what you're going to do is for number 1, you're going to find the two different parametric equations that you learned in class. So we know that x equals v cosine theta t and y equals sine theta t minus g, which is gravity, either in 9.8 feet per second or, meters per second, or the 32.17 meters per second. And then we know that, feet per second for the 32. And then we know that since we're in meters per second, we're going to use 9.8. So for the x parametric equation, you're going to get x equals 34 cosine 45t, which simplifies to 17 radical 2t, because cosine 45 is rad 2 over 2. And then for the y equation, you get 34 sine 45t minus 9.8 2t squared plus 13. That plus 13 is crucial because we have a initial height of 13, kind of like with a line, the b value, in a sense. But it's c in this one because it's a quadratic. This simplifies to y equals 17 rad 2t minus 9.8 t squared over 2 plus 13. And these are your two parametric equations right here that you will use later on to solve. So with number 2, it says determine how long the ball has been in the air. So what you're going to do for number 2 is to determine how long the ball is in the air, we're going to try to find the x-intercepts, the roots, the solutions, and it's going to be the farthest one. So it's going to be the positive one, or the more positive one. So what you're going to do is use quadratic formula. So negative b plus or minus the square root of b minus 4ac all over 2a. So here, this is the equation. You get negative 17 rad 2 minus, or we're going to use the minus one. Well, you're going to try both to figure out which one is more positive, but the minus one ends up being more positive. So this simplifies to 28.858. So what you're going to do is find negative 17 rad 2 minus 28.858 over negative 9.8. This equals 5.398 seconds, and that's how long the ball is in the air for. And then for part 3, it says determine how far the cannonball traveled in the air. To find how far, what you're going to do is multiply that x parametric equation, this one up here, with the t, which is how long it was in the air for. So we have x equals 17 rad 2t, multiply this number or this parametric equation and this number, you get 129.776 feet. And that's how far the cannonball traveled. And then for part 4, what you're going to do is you're going to try to find the x-coordinate of the vertex. So what you do for this one is negative b over 2a. You got negative 17 rad 2 over 2 times negative 9.8 over 2. This equals 2.453 seconds. And that is when the cannonball reaches maximum height. And then with part 4, to determine the maximum height, you're going to plug in this for your t. So then you get y equals 17 rad 2 times 2.453 minus 9.8 over 2 times 2.453 squared plus 13. And this equals 42.49 feet, which is the y-coordinate of the maximum, which is how we find the maximum height reached by the cannonball. Thank you.